The point of this presentation is to give you an overview of the framework, but also to receive your feedback. The framework has been recently committed. It's I have been receiving the feedback since I delivered it and working on addressing it. So I definitely welcome your feedback, and I apologize if it sometimes seemed rough around the edges, but I'm committed to getting it in good shape. All right, with that introduction, a bit of background about this topic. So in Papyrus, as you know, it's a tool that allows defining multiple domain specific modeling languages on top of UML. In fact, beside UML itself, there are other, and I call those architectural contexts. So UML itself is the base architectural context. It's a language. It's a modeling language. However, Papyrus also supports other languages and frameworks. One of the other languages is DSML. One of the other frameworks is, for example, Papyrus for Education. And I will, in a bit, distinguish what's the difference between a language and a framework in this new paradigm. However, these contexts, usually to support them in Papyrus, you will need to define their editing requirements and their viewing requirements. So, as you know, not all, some of those contexts like DSML, Papyrus for Education will make changes to the core functionality of UML, and they also will introduce their own new things. However, when Papyrus have all these contexts coexisting together, they sometimes cross each other and they target the same areas. So there's a lot of overlap between them, and what happens is now a user who's using one of these contexts may come across contributions from other contexts, which makes the experience less than ideal. It also is challenging for developers to be able to define their architectural context in isolation without being affected by the others. So let me talk a bit more in details about what does it mean to define a new DSML. It's usually about defining the editing behavior of this architectural context and the viewing behavior. So for the editing behavior, what Papyrus supports is it piggybacks on this framework from GMF called the client context framework to contribute editing behavior. And Papyrus has been using this framework to contribute some editing behavior through the element type framework. In the past, it was only extension point based, but more recently in Papyrus, it has been turned into model based. So you could create models of your element types or element type sets and contribute them to the GMF client context. The problem is that Papyrus uses a single context in Neon and the previous versions. This means that if two people are contributing two different languages or frameworks, they had to contribute their element types to the same GMF client context. And this causes an issue because there is little way to distinguish them, especially if those contributions are unaware of each other. Sometimes unexpected behavior can happen. Ideally, what you want is to have a GMF client context, a unique one for every architectural context, every language and every framework. And this is what the new framework will support. Second is the viewpoint idea. So now that I've taken care of the editing behavior, I want the viewing behavior. Usually the viewing behavior is defined by the representations that your language or framework present. For example, diagrams, tables, all these are kinds of representations that are available for your language or framework. So Papyrus introduced the idea of a viewpoint. A viewpoint is a collection of these things. So the idea is that you can define for a language one or more viewpoints that are a collection of representation kinds, diagrams and tables, and by enabling this viewpoint, you are customizing the UI or filtering the UI to only follow this viewpoint. In other words, you can see a limited number of diagrams, tables, you can see a limited number of create new element menus, the palettes, the property sheet, the explorer, all of these things will be limited to the viewpoint. However, Papyrus allowed only a single workspace or wide viewpoint, only a single one that you can say I have a viewpoint active, for example the UML viewpoint or the SysML viewpoint, and then all editors that you open in this workspace have to follow this viewpoint until you change it globally to something else. This obviously has great challenges because you cannot open multiple models of multiple architectural contexts following different viewpoints at the same time. You will need to keep changing globally like that, which is also not ideal. So now comes Papyrus Oxygen, which is trying to address these issues, these two issues, the ability to create architectural context in isolation. So to do this, we re-implemented the ISO 42010 spec. This spec was indeed implemented before in Papyrus when the viewpoint framework was introduced. However, it wasn't implemented in a way that allows us this kind of isolation. So we studied it again, and we had another go at re-implementing it, and the result is the architectural framework. So I won't go through the details of the spec itself, but I will show you how we adopted it in Papyrus. So architectural framework basically says it has at the root of it has a meta model called the architectural meta model. At the root of that there is just an architectural description element, which gives name, description, and qualified name. The root of models of this meta model would be architectural domain. And let me switch to full mode so that you can see it better. An architectural domain is, you can think of it, this is like the domain of the namespace that owns everything in an architecture. So inside the domain, you can define your stakeholders, which stakeholders care about this domain and what concerns do they have. So as you can see, they are both owned in the domain so that you can have reuse, as much reuse as possible. So you can have same concern expressed for different stakeholders without having to repeat the concern. Another thing that is owned in a domain is an architectural context. Architectural context is an abstract class. It's a superclass of both an architectural description language and an architecture framework. And the spec distinguishes these two kinds of artifacts. A language can define new kinds of representation kinds. So for example, language like UML can introduce all the UML diagrams, the 14 diagrams as different representation kinds. DSML also has some additional diagrams like the BDDs, IBDs, and some tables like allocation table, requirements table. So these are all things that a language can define. However, in addition to defining representation kinds, a language, through being a context, can also define viewpoints. Viewpoints is basically a collection of representation kinds that are owned by some language. So a viewpoint can, while you define the representation kind once in the relevant language, a viewpoint owned also by this language can say, okay, and I want to include these representation kinds in this viewpoint. So a language can have many viewpoints. So for example, a language like UML can come and say, I have these two viewpoints, one for analysis, one for design. The one for analysis will include use case diagrams, will include class diagrams, package diagrams. However, I don't want to include state chart and all these behavioral diagrams while I'm doing analysis, for example. Or it can include one type of behavioral diagram to specify the use cases with, for example, activity diagram. However, on the design viewpoint, it can have additional representation kinds, and there can be overlap between them. So viewpoints are not disjoint in this regard. In fact, a viewpoint from a language like DSML, for example, can also include representation kinds defined by languages like UML. So there is no requirement saying that for a language, its viewpoint has to only limit itself to representation kinds for this language. It can actually define representation kinds for other languages by just referencing them. So this design achieves a lot of reuse that in the past or before it wasn't possible. So people had to actually, for every viewpoint, have to define the representation kinds there, and the viewpoint kind of owned the representation kinds in the past rather than being owned by a language. And now a framework is a different architectural context that does not introduce new representation kinds, but like a language can also own viewpoints that references representation kinds. So the main difference between an architectural framework and a language is that a framework does not introduce new representation kinds, but it aggregates representation kinds from different languages and present them together as a framework. An example of that we use in Papyrus today is the profile framework. So while the UML as a language owns the class diagram, stereotype diagram, all these things, the profile framework includes in its profile definition viewpoint a stereotype diagram, for example, to allow and includes that from UML. Another example of a framework that we don't have today but can be defined is like DODAF. DODAF is an architecture framework from OMG, and it's possible, and it actually points to, it recommends the usage of some diagrams from UML, DSML, and maybe other languages, and it aggregates them into its viewpoint, and there is a methodology around using them. So that is the difference between a language and a framework, but together we call them architectural context. A representation kind always addresses some concern for some stakeholder. So you can express what concerns are expressed for every representation kind, but also a viewpoint can contribute more concerns in the model. So these are the main concepts in the architectural in an architecture model that you can build and contribute into your workbench. And representation kind here, if you can see, it's an abstract class with no concrete classes in this particular meta model. However, in another plugin, we elaborate further what's a representation kind. And this part of the work is very similar to what is the for its status in Neon. So Neon also introduces representation kinds that could be owned by viewpoints. So this part did not change really semantically. The only difference is that the definition of representation kinds have been split into various layers so that we can better manage dependencies. So there is an infrastructure layer where it just introduces a papyrus representation kind as a kind of representation kind, and that can own some bunch of rules without saying exactly what are. If you notice, this subclass is still abstract itself. So there are two kinds of concrete subclasses for a papyrus representation kind. There is a diagram, which is a kind of representation kind, and the diagram further has some rules that can define it, and there is also table. And if you see here, there are two kinds of tables. However, I'm working on eliminating this type of table, so there will be only a papyrus table. One kind of table to work with. So the details of how to work with these representation kinds, table and diagram, did not change much from before, so I won't touch on it much. I will focus more on the architectural contexts. These are the things that are new. So basically, this meta model. Okay, with this presentation, I'll switch to Papyrus. So just to give you an overview of where these meta models are in Papyrus, under Papyrus infrastructure, we've added the core architecture meta model under infra-core. So you can see infra-core architecture and its edit, and this is where the main architectural meta model is. Then there is one for the representation under architecture representation. So this part is not core. You'll find here the framework for representation. However, the diagram and table subclasses exist under GMF and under Natable. So under GMF, you have the diagram.gmf diag.representation, and under Natable, you see the Natable representation. So this gives you the diagrams and the tables as subclasses of the representation framework. And we also have, beside the meta models, we have infra.architecture, which is the main API. Beside the model API, these are the different utils, helpers that the code mostly interfaces with instances of these meta models through these APIs. So without going into details now, I will go to a runtime workbench to show you the UI parts that are impacting this or that are coming from this framework. I'll start with the preferences pages. So here in a workspace, you under Papyrus architectural context, you see which architectural contexts are contributed by the platform. And currently you see 3 contexts contributed. 2 in the software engineering domain and 1 under systems engineering domain. These architectural contexts are defined through extension points. So to see where those extension points are, under Papyrus UML and Papyrus SysML, there is plugins that ends with .architecture. These ones are the ones that contribute the models through extension points. So if you can see here, There is a UML.architecture, which is an instance of this meta model I show, and there is also sysml.architecture. These are the two models that contribute, and this is, by the way, sysml 1.1, not 1.4. I know the team is now working on adopting these this new framework to sysml 1.4. So these two models are contributed with an extension point. And this is the extension point. It just simply says there is this architectural model that is a contribution. Same with UML. And if I imported them here into the runtime workbench so that we can see how they look like, these models. So here is the UML architecture. And in there, I have defined the software engineering domain, and it has two stakeholders. One is a software engineer, one is a domain architect, and a bunch of concerns like profiles, use cases, structure, behavior. These are the concerns. For example, software engineer has concerns of use cases, structure, and behavior, while a domain architect, this is the person who's defining, for example, a profile, have the profiles concern. And I defined two architectural contexts. One is a language, UML, and one is a framework, which is a profile. For the language UML, I defined two viewpoints, analysis viewpoint and design viewpoint. And if you notice, for each of them, you can define which representation kinds you want to include. So for the design, you have these, for the analysis, I mean, you have these kind of representations included, where for the design, you have mostly all of the UML diagrams and tables except few, like use cases I did not put here. So it's a matter of just adding the representation kinds here to a viewpoint to enable. So for example, of course I did it based on my best judgment here. However, we can always change which diagrams show under which viewpoints if they make more sense. Beside the viewpoints, the language UML defines the actual representation kinds. So these are the diagrams and tables that are represented. And these were actually existing before in the old viewpoint framework. So the old viewpoint framework included all these representation kinds from UML. So what I did is I just refactored. I copied them from the old models into this new model. So as I told you, the meta model did not change in this part. So it was straightforward copy paste from the older models into this new model. So I won't go into the details of actually how to define those. This is the same as before. What you can do here now is you can share these things. So they don't need to be defined many times. They are just defined under the language and used by this viewpoint. Similarly, for the profile framework, in this case, it only defined a new viewpoint. The viewpoint is called profile definition, and the profile definition includes the profile diagram and the class diagram from UML as being part of the viewpoint. So it did not, as I told you, frameworks do not create new representation kinds. They just reuse ones from languages. So in this case, it reused the two languages from UML. Similarly, for SysML, we defined now the systems engineering domain that has a new stakeholder called the systems engineer, who has two concerns. In addition, to the concerns of the software engineer. So the software engineer, system engineer, maybe he has the same concerns as the software engineer. So he shares the same things as before, but he also adds now that he's interested in requirements and parametrics, which are the new concepts introduced in SysML that did not exist for UML. So as you can see, I didn't have to redefine the concerns. Really, I reused them from the UML dot architecture, and I reused them here for the stakeholder. And SysML as a language introduced two new viewpoints: systems analysis, system design, and introduced the unique diagrams that the SysML language talks about. BDDs, IVDs, parametric diagrams, requirement diagram, and two tables, requirement table and allocation table. And these viewpoints from SysML, for example, the analysis, will use some diagrams from SysML, but also from UML. So it reuses the use case diagram from UML, but it also adds the requirements stuff and a BDD into its analysis viewpoint and the systems design. It has a mix of SysML, the new stuff, and UML, the old stuff into it. Again, here, for example, SysML does not talk about some of the UML diagrams, so that's why the list of diagrams available in a SysML model will be less than the diagrams available in a UML model. And it's a matter of adding or removing these representation kinds from a language to say whether they should be in these viewpoints or not. So these are the two models contributed in an extension point here. And when we go to the preferences, these are the ones that we see. Software engineering. So let's start with the domain, and then which contexts are under the domain. And these checkboxes a user they will be checked by default, but the user can uncheck them to control which ones they want to see in the workbench. So when you go to create new models, which ones will be offered as context to use to create models, or if you want to switch from one context to another, which ones will be available to you based on these checkboxes. By default, UML is the default context, but you can use the button to change which language should be default when you're creating new models. Additionally, you can add other models that are not contributed in extension points, but rather defined in a workbench, in a workspace. For example, you can define new architectural languages here dynamically with some caveats I will talk about. So when you create one, you are creating an architectural model. So following the architectural model, you give it a name, and then you choose the root. The root here will be a domain, architectural domain. So once you do that, you will get the editor for your language. So here it's just this completely fake like toy architectural model that I was playing with. It's not real. It doesn't represent any real language. So I defined here, so I did two things. First thing, I thought, okay, why not extend the SysML language with another viewpoint? So one thing the framework allows is extension of existing contexts. So you don't. It's not only about defining new ones, but you can also extend existing ones. The way to extend the existing ones is to follow the same namespaces. So for example, here I created a new architecture context and I named it SysML. So in fact, it starts with the domain. With the domain, I called it systems engineering. So this means I am making a contribution to the systems engineering domain, which was already introduced by SysML in the SysML model. And I want to additionally contribute to SysML, so I define SysML. Notice that here I did not put values for the rest of the fields. So the way it works is I just need to identify the name. The rest of the fields I don't need to specify. They will be inherited by this other model. So one of the models that contribute SysML needs to define these other fields, and just if you want to add an additional one, you can add one and just specify the name, and the rest you don't need to specify. So in this case, I created SysML, and then I created another viewpoint. I just called it systems allocation. And when you define, this brings another point where I want to revisit the meta model in. So let's talk about what are some of these attributes that you are specifying here in an architectural context. So in an architecture context, you have an ID. The ID, so beside the name, it has a name by being an architectural description element, but it also has an ID. This ID is the same ID that will be used as a GMF client context. So this is where the architectural context meets GMF client context by using the same ID. In fact, these IDs, so for example, Papyrus has a default ID that is currently used by the UML architecture, UML language, but the SysML language and the profile framework, they introduced IDs that were not used before. So what this means is when you define these frameworks and give them this ID, the framework will, when parsing these models, will use these IDs to register GMF client context with. So this is an important field to set. You can have some icon showing for your context in the UI, extension prefix. Usually your models will be called something.uml. However, if you want a prefix to that, for example, the profile framework introduces .profile, so something.profile.uml. So you can specify that my context has a prefix here, and you can specify it here. You can also specify the list of element types that will be registered for this context using this ID. So GMF context will be this. All the contributions of element types that you used to do before, from element type set configuration models, you can now do here in the context of your architecture context. See, my architecture context has these element types. And this is now, it's interesting because in the past, you had all kinds of plugins that were trying to contribute these element types. For example, all the diagram plugins, all the table plugins from UML, SysML, everything, they were all contributing element types to this single default client context. This presents a challenge because now there is a strong coupling between these these plugins, the contributors, and the context. So it sounds like they know about the context they want to be in. However, with this design, the context is the one that knows about the element types. It's not the other way around. So although these element types may indeed still be defined by the different plugins, the place where you link the context to the element types is inside the plugin that defines the context. It's the architectural context itself. So in this case, the UML context says, I want to use these element types. And the SysML context says, I want to use these element types. It's not the other way around. So this allows the definers of DSLs to control exactly which element types will be included in their domain. Of course, this is not a closed world, because somebody can come and extend the architectural context by contributing another one, like I just showed you for SysML, and they can come and add element types. So when I told you when you define a new one, you only create a name, that wasn't very accurate, because you can still, on these things that have multiplicity star, like the viewpoints, like the element types, you can create new contributions in the newly defined fragment, and then the contributions from all the fragments will be merged together. So indeed, the original definition of the languages and frameworks will define the ones that they know of, but somebody else can come and define new fragments with new element types or viewpoints. So this needs to be done for every architectural context, and these are the ones that will be used for this architectural context. So if you are defining a new one, you will need to redefine which ones are added. Of course, they can be the same. They can exist in the, you can include the same element types in both UML and SysML, but you need to define them per architectural context you define, including frameworks. Because sometimes also frameworks introduce changes. So to control exactly which behavior are included and which ones are not included, you define it for the framework or the language specifically by controlling this list. What else? When you define a language, you define the meta model and the profile that represent these languages. And usually the meta model is UML, but in the future we can think of non-UML languages, and a list of UML profiles you can define for your language. Two important attributes is a creation command and a conversion command. So the creation command is a Java class that you point to that is responsible for creating the root of your model. So the framework will create the model set, the DI, the UML, the notation, all these things. However, it does not create the model root inside of your model. To do this, your context has to give a Java class that is responsible for instantiating the root of your model. So in the case of UML, this will be creating just a UML package at the root. For the profile framework, this will create the profile at the root. For SysML, it will still be the package, but applied to it the SysML profile. So this command is a class that you need to worry about when you define architectural context to exactly control how your models will be created. Conversion command, on the other hand, is one that you can optionally supply to control if you are switching from another context into this context. You have an opportunity to run a conversion command here to be able to convert a model from one context to another. So let's say you're switching from UML to SysML. You can contribute this conversion command to, for example, apply the profile. Or do whatever you want. So currently I do not have an example of implementation of this, but this is basically a command that will get the model set as input, and then you are able to do all kinds of refactoring that you want to make the model a proper instance of this new architectural context that you are moving to. So you can implement it the way you want. And then I may come to this meta model again at some point to describe some more classes. But coming back here, this is the SysML fragment we are defining with a new viewpoint to it. I did not add any element types here, new element types, just a viewpoint. And I just decided to create a dummy diagram here called allocation diagram and include it from the representation kinds in this view. So this viewpoint only has this representation kind. Additionally to this SysML fragment I defined here, I also defined a new architectural framework called DODAF, for example. Of course, this is not complete, this is just an example. So in DODAF, I created a new viewpoint called defense modeling, and I decided to include with it all the representation kinds from SysML. So in order for me to do this, I had to bring the sysml.architecture loaded into this resource set. So I used the usual load resource. I navigated to the sysml dot architecture in the workspace. So currently this load dialog is limited to things in your workspace or file system. It doesn't currently load things from the platform, deployed platform. So the caveat I use now is when I load from the resource and browse the workspace, for example, to find SysML, if I want, usually what I want is I don't want to use the resource version. I want to use the plugin version. So I come here and do plugin instead, and I use that. So everything loads with plugin so that it can be found when this model is deployed. However, we can in the future envision adding another button to browse from the platform here, so that I don't need to do this. So once I have the SysML loaded here, and I'm here, I can define my representation kinds. I see all the SysML, and of course, because SysML also includes UML, I see all the UML ones, and I can decide to include any of their representation kinds in my new viewpoint. In this case, I chose to add them all. So, okay, so my model here has just a contribution to SysML, and it has this new DODAF framework. And it's in my workspace. Of course, this model can be like Vue and SysML contributed with an extension point, but in this case, I'm doing that. Going back to the preferences, I use this button, other architectural models, to now specify this architectural model here. And when I do that, you see that there is a new framework under the same domain that shows up. There is also the SysML addition, but it doesn't show any different here because I don't show all the viewpoints here, but the contribution of the viewpoint will show up when I create new models. So this brings me to the next UI element, which is the new model wizard. So you create a new Papyrus model, and here you see which contexts from the preferences were enabled. You see them here, and the default one gets selected by default. So you see the contexts, and you see the viewpoints that are offered by this context. So if I selected profile, I see the profile definition. If I selected UML, I see that. If I selected SysML, I see the ones from before, but I also see this new allocation viewpoint that I added from the fragment. If I selected DODAF, which is the new thing, I see this viewpoint that I added from the architectural model here. And when you follow with these things, for example, UML, same page like before, the model name, and here you only see the representation kinds that are coming from that context. So only the things that are from the context you see here. For example, you see all the UML stuff here. However, if you went back and you said, for UML, I only want to work with design or analysis, not design, as a default. So when you create a new model now, these viewpoints will be selected in your model. So for example, on the analysis, you see a smaller set of diagrams that are only for analysis. And if you selected profile definition, you see this is the extension, the prefix to the extension that comes with it. And you only see these diagrams which are in that framework. Similarly, if you chose this DODAF, you only see the things that we added in this DODAF one. If you chose DSML with all of these things, here you see this allocation diagram that I added from the dynamic model, and the rest are coming from the normal viewpoints from DSML. So the idea here is that when you create a model, you choose which context it belongs to. It has to belong to one context only, and any number of viewpoints offered by this context. So let's say we will pick both here, and then I will not create anything by default, so I finish. Now it creates the element the usual way, and as it's creating the root of the model, as I said, it invokes this creation command, which creates just a simple package at the root, or a model in this case rather. So now let's look at this DI model in a textual editor. You will see two new objects showing up at the root of this DI resource. You see the context, which context is this model following, and you see which viewpoints are used. So I used the UML context, which reuses this default context from Papyrus before, and these two new viewpoint ID. These objects, let me go back to the meta model. Are introduced here. Architectural description with the context ID, and architectural description preferences with viewpoint IDs. These two objects are the ones that are inserted at the root of the models to show which context, which viewpoints. And we decided to make them by ID instead of by an actual reference to be able to switch the models in the workspace without needing to break the references. So instead of having a hard reference, it's like a soft reference by ID. So the idea is that these contexts need to exist in the workspace that you are opening the model in. And as long as the IDs match, they will be used. Similarly for the viewpoint. And if you are familiar enough with the DI model, when you switch the editor to be private or shared, you may know that the layout information can live in under this DI model or under a sash model stored in the preferences. So these two objects, the new ones, they are always inside this DI model. They don't switch to the local preference store. So they are always shared with others in the model. And they are kept separate objects so that maybe in the future we can decide to make some of them shared so that they will go back and forth between this DI model and the sash model. But for now, they are always in this DI model. All right, so what happens now is when you have created a model following a certain architecture context, Now, when you go to new diagram and new table, you see the things that are allowed by this context that you chose and by its viewpoints. So if we go back all the way down here to the viewpoints, these two new addition to the menu allows you to switch the context and switch the viewpoints. So here you can see that the two viewpoints that we selected in the new model wizard are selected by default. However, I can unselect them, or I can bring the dialog to switch to another context. So first, for example, let's create here class diagram. The class, and create also a use case diagram from the analysis viewpoint with the use case. Now you see both of them showing up in the Explorer because they are contributed from the active viewpoints. However, if I disabled the analysis viewpoint, you see that the use case diagram disappears. It disappears because now the viewpoint that originally contributed it or allowed it is no longer active for this model. So what you see only are the diagrams that belong to the active viewpoints. If I, of course, switched also the other one, both of them disappear. So this is your quick switching. And now I enable analysis and I see both because analysis actually contributes both. So you can, switching analysis only will bring both of them back. So switching a viewpoint is, it doesn't structurally change the model itself. It doesn't refactor anything in the model. It purely helps you filter down the UI. It controls only the user interface. So here you will find it will allow you to filter which viewpoints are, which diagrams are. You can see it does not delete those diagrams. So the diagrams are not actually deleted by switching viewpoints. They are just hidden from the UI. And if you want to switch the architectural context, you can switch to another one, for example, SysML. And at this point, you can also switch the viewpoint. So you can use this dialog to only switch viewpoints, similar to this other context menu. So you can bring it up and only switch the viewpoints, but you can also switch the architectural context with the new set of viewpoints. So when you do that, you will get warned that doing architectural context switch is now may refactor your model. Will do changes to your model. For example, applying SysML may apply the SysML profile to your model if it wasn't applied before. Or I don't know, all kinds of things. It's an extension point, and the command can do whatever it wants here. So you are just warned, and then you can accept, and the conversion happens. Of course, in this case, I didn't implement a conversion command really for SysML 1.1 because there was no time for this. But I imagine the SysML 1.4 folks will implement one to convert a UML model into SysML model. But now, since we are in the SysML design, all the viewpoints now become systems-like. They're not software viewpoints anymore, and the context is switches all to and in that case, if the new viewpoints did not have these two kinds into them, they will disappear as well. It just happens that SysML also contains these new things, so you still see them. switch back to UML. All right, so this you saw pretty much all the impact on the GUI for this architecture framework. It's not much yet. However, going forward, I know that Florian is arranging that we can link more and more of the UI to be linked to this new framework. For example, when we come here, we can have this new child menu, all these things, including SysML. Like, you see, I'm on a UML model, yet I am seeing SysML contributions there on this model, which shouldn't be the case. So when this new child framework is properly linked to the viewpoint framework, you should be able to hide these contributions that do not make sense to the active context of the model. Similarly, maybe property sheet and other things, we will try to make all the UI contextual to the context applied to the model, so that you will see less clutter in the UI. All right, I'll switch back to the code here to show you some other places or some interesting APIs. So going back to infrastructure, under architecture, this is where most of the APIs are. So this architectural domain manager class is the main interface that loads the models. So this is the manager of the architectural domain models. In particular, it manages the ones that are contributed from extensions and contributed from preferences. So it gets both models. It listens to the preference store for any changes, reloads the models from the preferences, and so this is your entry point in asking questions about which models are loaded and active in the workspace. It has APIs to get, for example, the visible architectural contexts, get the ID of the default one that is currently selected, get architectural context by ID, get viewpoint by ID, and so forth. So anything related to architectural model management will be here. Then there is also so this manager, as I told you, we support merging of those architectural models. So in fact, there is this manager, this merger class. This is the class that merges all architectural domains into, it merges them together so that you can see contributions from different artifacts. The preferences is the manager of the preferences store regarding architectural domains. So you can ask it for all the things that you can do in the preference page. You can ask for these things through API of this class. Finally, the utils. This one is specifically for the architectural description for the things that are for these two objects that I mentioned, the architecture description and the architecture description preferences. So like anything related to the DI model and these two objects, manipulation of this is within this architecture description utils. So you can ask it which architecture. So you load it with a model set in the constructor. Then you can ask a question: give me the architectural context for this model set. Give me the viewpoints that are in this model set, and so forth. It also has APIs that are called by the UI elements. For example, when it creates a new model, it has an API here to create a new model. So this is also your entry point to programmatically define components that interface with this framework. So, for example, you don't need to invoke the regular wizard to create model. You can create your own wizard or your own UI element that creates architectural models by calling this API. Similarly, you can switch architectural contexts and switch viewpoints by calling these APIs. These ones allow you to switch programmatically context and viewpoints and create more new models. And this is meant to be, for example, you can implement your own methodology by programmatically switching context and viewpoints at certain times to help the user. Instead of the user having to switch manually through the UI, you can auto switch for them these things. So it's meant to enable these kind of use cases. Similarly, if you are interested not in new automation, but you are interested in listening to events of what's happening, you can also register listeners. And the listeners that you can do, you can listen to architectural description events. So you can listen to context being switched. You can listen to architectural viewpoints being switched through implementing this interface and registering it with in an extension point, actually. So when you register this interface, there is an extension point that you can use to register those listeners. So once you register the listener, you will get notified by changes to architectural context stuff. You notice when you create a new model, this will when you switch, you will it gets the contribution from all conversion. It will get the it will query for the conversion command, and it will query for the creation command from the registry. But at the end, there is some listener to the DI model changes. In this case, we are interested in the structure, the context changes. So this is the listener that I have put into the DI model. It's an adapter that listens to architecture description events and events on the preferences and fires off the notification for your listeners, so you can follow up on what's going on and react. And basically, when you're reacting here, you are only changing the UI in response to changes of the context or viewpoint. You're not supposed to do other changes. If you are really interested in doing changes that are part of the action of switching context and switching viewpoints, you contribute commands here. You don't contribute listeners. When you contribute commands, then you can do that. And to contribute commands, there is two interfaces. There is the model creation command and the model conversion command. So by contributing these things, aside from the model, the ones that are in the model, in the architecture model, you can also contribute ones through an extension point, like this. And you can use this command provider extension point to provide, you can add to the creation and you can add to the conversion through these extension points. So you can contribute new architecture models, you can contribute new commands, and you can contribute listeners to the architectural framework. The other piece here is the UI. So this plugin provides all the UI pieces that I talked about, the preference pages, the actions that do the switching, the architectural editor itself, and the navigator. If you remember, I said that in the Model Explorer, these elements they can disappear based on which viewpoint is active. In fact, this is implemented by adding a new filter here in the profile, the unsupported diagrams and tables filter. So this filter is there to filter out the representations that are not supported in the viewpoints. By disabling this filter, you can see all diagrams and tables regardless of if they are supported or not. So this way you can see all the things that are in the model without regard to the active viewpoints. For example, you may some users may be surprised why my diagrams are not there. This is because it's not covered by the viewpoint. However, if they really want to see them without switching the viewpoint, maybe stale diagrams or editors from viewpoints that got deleted dynamically or whatever situation they want to see them, they can come here and unselect this, and they will see everything. This way they can delete them or do anything with them. Okay, I think I pretty much covered everything I wanted to say, and if you have any questions, I can take them at this point.
So thank you, Mayet, for the presentation. So yeah, if you have questions, please go ahead.
One thing I also wanted to point out is when you make changes to dynamically contributed architectural models, in order to tell the framework that you did that, you just need to go to the preference page and do another apply or OK so that it gets reloaded. Because this is saying which models you use, but it will not be aware that you have changed it. So in order for it to see your changes, you just reload it by going to the preference page, hitting OK, and it will reload your dynamic contributions.